ladies and gentlemen. My name is Stan Forrester, and we are at the end of week 1 for NS130. Are we alone? One of the objectives of this course is not just to look at science as a body of knowledge or as a practice for generating new knowledge, both of which are very true. But science is also a highly social endeavor. Human beings that get grumpy, human beings that get fixed in their positions. And so how do we arrive at a scientific consensus? What does that mean? And so what we did is we had you guys go through the Drake equation and give us your estimates prior to actually learning anything. And give us your best estimates. Now, let's go ahead and let's take a look at that data. Now, of course, as you begin to learn, some of these estimates are going to change, especially when you begin to discuss them with your classmates. All right, so let's take a look at this first one here. Here's your estimate for R star, the rate of star formation. No, we have all of them here. Okay, so here's the fraction of stars with planets, fraction of planets that are Earth-like. Okay, but for this first one here, I've arranged all of the data for R star in numerical order from smallest to largest. We might ask ourselves, what's the best descriptor of that distribution? And some people might be tempted to say the average. But if you were to average this number here, which is very, very close to 0, with this other number here, which is 729 million, you would actually be somewhere between your 18th and your 19th value. And that would not be a good descriptor of the center of this distribution. It turns out there's actually 19 values here because row 1 is a heading. Okay, so the center of this distribution, the middle value, is actually 7.293. Okay, and then we would ask, okay, so how spread out are these? Well, let's take the median of all of the values that are less than this. That would give us a lower bound. And the half of the values that are, what's the median of the values above that 7.293? And that's going to give us roughly half of all the best guess values. Okay, so that's your consensus. Like, if you had to pick somebody who's right or wrong 50%, somebody in that group there is going to be right 50% of the time. All right, and so we used what are called the quartile functions. Here's our range, D2 to D20, and F1 means we're for the first quartile. And I better hit enter before I get rid of that. And it turned out that that was 7.2993. Again, we did pick that out. And 79.5. If we go back up here and look at our third quartile is going to be between 15 and 16. So the average of 140 and 19 is 79.5. And what we would say is that of all of our best guesses, 50% of them fall between 7 and 79.5. That's probably actually the more interesting value than the median, but we're going to have that in there anyways. We've done that with all of the remaining values, and if we take a look here, if we were to try to display our first quartile, third quartile, and our median all on the same graph, so we have something close to 0, something still pretty close to 0, and close to 12,000. That's not going to display very well. They're all going to be crowded up at the very bottom. One technique we have for displaying data with large discrepancies in scale is something that's called a log plot. So what I'm going to do is I'm going to take the log of each of these values. All right. Now you can't take the log of 0, so I just plugged in log of 10 to the minus 6, but we're not really interested in that one anyways. What we're mostly interested in is the spread in values between our first quartile and our third quartile. What's going to capture about half of our estimates, or half of our best guesses. And if a consensus does develop, we're going to see this box shrink down. It's also quite possible that we'll end up with a group of pessimists and a group of optimists, and we might end up with two separate distributions. That is always possible. That happens in the scientific world. We call it competing models. And how do we resolve that? Well, in the end, it's evidence. So let's see how it works out, and I'll see you next week. Okay, bye.